Alright guys, so just a brief explanation because some of you have had questions over the weekend about how to do the ConeOpolis project. Just to remind you one more time, this is a volume only calculation set of problems. You're not calculating surface area. The answers that I've put in Canvas are approximate answers. Apparently, the person that worked these problems out rounded to the first decimal place on whatever calculations she made. So your answers might be slightly different, but they're not going to be very different. Maybe off by a decimal, by 1/10 or less. I mean, it's not going to be more than 2/10 of a difference. So this one right here, as I explained in class, is problem number 1 is a rectangular prism with a triangular prism on top. So if you want to picture it like this, the bottom is a rectangular prism. It is three-dimensional. Remember that for a rectangular prism and a rectangular prism only, you can do length times width times height for the volume. So you have all three numbers. Sitting on top of that is a triangular prism, and the triangular prism is not sitting on its base because the bases of the triangular prism are the triangles. So you need to make sure that when you're doing area of the base times the height, the area of the base for the volume, because that's how you find volume of a prism, the area of the base would be the area of the triangle and the height would be right here. So let's go back and look at what that looks like on the building. So on number 1, there's the bottom. Here is the rectangular prism. And sitting on top of it is a triangular prism where this is the base and this is the height. Problem number 2 is 2 rectangular prisms. They are stuck together, but here's one rectangular prism, and back here is a second rectangular prism that's attached to it. Number 3 is very much like number 1. It's a rectangular prism with a triangular prism for the roof. Number 4 is a pyramid. Remember that the volume of a pyramid, you do have to use 1/3 area of the base times the height. So it's a pyramid with a square base. And on top of it, you have a sphere. Remember the formula for the volume of a sphere is 4/3 pi r cubed, but 14 is not the radius. 14 is the diameter of the sphere. So do not use 14 as the radius because you will not find the same answer as the answer key shows. On problem number 5, once again, you have a rectangular prism, but on top of it, instead of it being a triangular prism, you now have a pyramid sitting on top of it. So that's a pyramid with the base, that's a 12 by 12 square, and a height that's 9 feet. Remember, for pyramids and for cones, you have to use the 1/3 area of the base times the height for the volume. Number 6, the bottom is a cylinder and the top is a hemisphere. So it is a full cylinder, but only half of a sphere. So remember, for a sphere, 4/3 pi r cubed, but then you have to cut that sphere in half because it's only a hemisphere. Number 7 is the one that I was talking about in class where that piece is pretty confusing. And as I told you in class, that portion of the building is half of a cylinder. So it's a cylinder that's cut in half this way, so it's only this half of the cylinder right here sitting on the front of the building. And on top of that half of a cylinder is half of a cone. So this is a cone, and the cone again is chopped in half vertically so that the back of the cone, the back of half of the cone sits flush against that wall. So it's half of a cylinder with half of a cone on top of it for problem number 7. And that does look confusing. Don't forget the little cylinder for the chimney. because that does count as the volume. The playground, we have a triangular prism. Again, the base of the triangular prism is the triangle. This is the height of the triangular prism. We have a second triangular prism right here with the climbing wall, or slide, or whatever that might be, not sure. But again, the base of the prism is the triangle. So this triangle right here is the base of the triangular prism. The height of the prism would be 3. The swimming pool, no, that's not a swimming pool, that's a merry-go-round, I guess. Not sure what that is either, but it's in the playground. Might be a swimming pool, might be a merry-go-round, but that is a cylinder. For building 11, the gazebo is a cylinder with a cone on top of it. And number 12 is a triangular prism, and now it's actually sitting on its base with a triangular pyramid sitting on top of it. So hopefully that clarifies just a little bit. All right. And again, the answers are in Canvas.